So yesterday we have seen the measurement of length using vernier calipers, and in vernier calipers I have explained you the description. I have shown you the diagram. I have also explained you the method of measuring the length. Even I have given you the demo videos. Even the other two jaws, J3, J4 and the lever also have got the applications. They'll be used to find the internal diameter of a beaker and the depth of the beaker. You can find the volume. Many applications were discussed in the video. So if you see them, you will get a clarity. I'll just show you one video what I shared yesterday with a brief explanation so that you will get a clarity, right?
Okay, sir.
Okay, sir.
ఏదో ఫోన్ వేస్తుంది
हेलो दोस्तों, आज हम फिर से स्टार्ट करते हैं वर्नियर कैलिपर का जो हमारे 11th क्लास का थर्ड एक्सपेरिमेंट है।
Sir, you're not sharing your screen.
वॉल्यूम निकालेंगे वर्नियर कैलिपर की मदद से। तो सबसे पहले हम इसमें बीकर का डायमीटर निकालेंगे, फिर इसमें हम बीकर का डेप्थ निकालेंगे और बाद में डायमीटर और डेप्थ की मदद से वॉल्यूम का फॉर्मूला यूज करके बीकर का वॉल्यूम निकालेंगे। तो देखते हैं कि हम बीकर का डायमीटर कैसे निकालेंगे। सबसे पहले तो ये रहा हमारा बीकर। इसके जो इंटरनल जॉज हैं,
yes, J3, J4 we called. Do you remember yesterday?
Yes, sir.
Yes, sir.
External jaws are J1 and J3 and internal are J2 and J4.
Exactly.
फिर निकाल लेंगे इसको और अब इसकी रीडिंग ले लेते हैं।
Just see once again.
फिर इसमें हम बीकर का डेप्थ निकालेंगे।
This is vernier
और बाद
calipers.
में
This is
diameter
vernier
और
scale.
depth की मदद से
This is
वॉल्यूम का
main
फॉर्मूला
scale.
यूज करके बीकर का वॉल्यूम निकालेंगे।
Vernier scale you can see.
कि हम बीकर
Vernier scale you can see 10 divisions are there. Okay. Yes or no?
Yes, sir. There are divisions.
And this is main scale. This is 1 centimeter. Starts from 0, 1, 2, 3, etc. So when the two jaws are in contact, 0 of the main scale should coincide with 0 of the vernier scale. Then it is free from 0 error. Yeah, this instrument is not having any 0 error. If you press the lever, this jaw will be moving on the main scale. This will be moving on the main scale. So value of the 1 centimeter is divided into 10 divisions. So each small division is equal to 1 millimeter. Value of one main scale division is 1 millimeter by 10. So least count will be 1 by 10 millimeters. That is 0.1 millimeter. If you want to express in centimeters, it is 0.1 by 10, 0.01 centimeters. That is the least count. So this is how he is explaining the way of measuring.
डायमीटर निकालेंगे, फिर इसमें हम बीकर का डेप्थ निकालेंगे और बाद में डायमीटर और डेप्थ की मदद से वॉल्यूम का फॉर्मूला यूज करके बीकर का वॉल्यूम निकालेंगे। तो देखते हैं कि हम बीकर का डायमीटर कैसे निकालेंगे। सबसे पहले तो ये रहा हमारा बीकर। इसके जो इंटरनल जॉज हैं, इसको इस तरह से बीकर के अंदर फंसा कर निकाल लेंगे इसको और अब इसकी रीडिंग ले लेते हैं। रीडिंग लेने के लिए वही तरीका है। वर्नियर स्केल का 0 मेन स्केल के जिस मार्क के सामने आ रहा है वो हमारी मेन स्केल रीडिंग हो गई। तो इसमें हमें दिख रही है 6। नंबर ऑफ कोइंसाइडिंग वर्नियर स्केल की जो लाइन मेन स्केल की लाइन के सीध में आ रही है वो नंबर ऑफ कोइंसाइडिंग हमें दिख रहा है 5वीं लाइन मेन स्केल की लाइन के सीध में आ रही है। इसका मतलब नंबर ऑफ कोइंसाइडिंग हो गया 5।
It is vernier coincidence. What he is telling is vernier
उसके
coincidence.
बाद
Fifth division is
लीस्ट काउंट जो
coinciding.
हम जानते हैं 0.01 सेंटीमीटर है। इन तीनों वैल्यूज को डायमीटर में फॉर्मूला इनपुट करेंगे। फॉर्मूला होता है मेन स्केल रीडिंग प्लस नंबर ऑफ कोइंसाइडिंग इनटू लीस्ट काउंट। तीनों वैल्यूज को पुट करेंगे डायमीटर।
Vernier coincidence is calling
दूसरा
number of
डायमीटर निकालने
coinciding.
के लिए हम क्या करेंगे, फिर से इसको जो बीकर को हमने पहले लिया था जिस जगह पे, थोड़ा सा इसको रोटेट करके अलग जगह पर इन दोनों इंटरनल जॉस को फंसाएंगे और फंसाने के बाद फिर इसको निकाल लेंगे।
Yeah, this is main scale.
वर्नियर स्केल का 0 जिसके
Reading
सामने आ रहा
just before vernier 0.
नंबर ऑफ कोइंसाइडिंग, बार नंबर ऑफ कोइंसाइडिंग चेंज हुआ है जो कि हमें लग रहा है कि ये है नंबर ऑफ कोइंसाइडिंग। लीस्ट काउंट वही है 0.01। तीनों वैल्यूज को डायमीटर के फॉर्म में पुट करेंगे, डायमीटर निकालेंगे। 2 डायमीटर निकालने के बाद तीसरा डायमीटर फिर निकालेंगे। बीकर को थोड़ा सा रोटेट करके फिर से इंटरनल जॉस को फंसा के और इसका हम तीसरा डायमीटर निकालेंगे। तीनों डायमीटर निकालने के बाद तीनों डायमीटर्स का मीन निकालेंगे। जो मीन डायमीटर आएगा वो हमारे इस बीकर का फाइनल डायमीटर हो जाएगा। इसके बाद इसकी डेप्थ निकालते हैं। डेप्थ निकालने के लिए क्या करेंगे, जो वर्नियर कैलिपर की स्ट्रिप है इसको बीकर की जो डेप्थ है उसके बराबर तक इसे खोल दो। जब ये बॉटम में टच कर जाएगी स्ट्रेट तो इसकी रीडिंग फिर से ले लेंगे।
Same MSR VC.
रीडिंग लेने का वही तरीका है। तो ये हमारा मेन स्केल रीडिंग, वर्नियर स्केल का 0 मेन स्केल के जिस मार्क के सामने आ रहा है मेन स्केल रीडिंग हो गई। नंबर ऑफ कोइंसाइडिंग
I think is 9.8, 9.9.
3 है और लीस्ट काउंट वही 0.01। तीनों वैल्यूज को पुट करेंगे और इस पर डेप्थ का फॉर्मूला भी वही बनेगा जो हम नॉर्मली यूज करते हैं, मेन स्केल रीडिंग प्लस नंबर ऑफ कोइंसाइडिंग इनटू लीस्ट काउंट। ठीक है, अब फिर से इसका डेप्थ दोबारा से निकालते हैं। स्ट्रिप को फिर से वही खोल के बीकर को थोड़ा सा रोटेट करके किसी और पोजीशन पे रखते हैं और जब तक स्ट्रिप को खोलेंगे जब तक बॉटम से टच ना करें। टच करने के बाद जब टच कर जाएगी फिर से इसकी रीडिंग लेनी है। वही मेन स्केल रीडिंग लेनी है। वर्नियर स्केल का 0 मेन स्केल के जिसके सामने आ रहा है सेम वही 9.9 और नंबर ऑफ कोइंसाइडिंग जो लग रहा है नंबर ऑफ कोइंसाइडिंग इसमें 3 है इस बार भी और लीस्ट काउंट वही 0.01 और तीनों वैल्यूज को फिर से फॉर्मूले में पुट करेंगे और फिर से तीसरा डेप्थ निकालकर अलग पोजीशन पे बीकर को रोटेट करके अलग पोजीशन पे फिर से हम तीसरा डेप्थ निकालेंगे और तीनों डेप्थ निकालकर तीनों डेप्थ का मीन निकाल लेंगे और जो मीन डेप्थ आएगा वो हमारे बीकर का फाइनल डेप्थ हो जाएगा। और इस तरह से हमने इस बीकर का डायमीटर निकाल लिया, डेप्थ निकाल लिया और डायमीटर और डेप्थ को फॉर्मूले में पुट करेंगे। इसका वॉल्यूम का फॉर्मूला होता है बिकॉज ये सिलेंडर है, सिलेंडर का वॉल्यूम निकालने का फॉर्मूला होता है पाई आर स्क्वायर एच। तो आर जो कि रेडियस है जो कि डायमीटर का आधा करके निकाल लेंगे, एच जो कि डेप्थ है जो कि हमने वर्नियर कैलिपर की मदद से डेप्थ निकाला और रेडियस और डेप्थ की वैल्यू को पुट करके फॉर्मूले से हमें वॉल्यूम इस बीकर का मिल जाएगा। तो दोस्तों इस तरह से हमने 11th क्लास का अपना ये कंप्लीट किया जिसमें हमने इस बीकर का वॉल्यूम निकाला। ठीक है, अब हम नई वीडियो में मिलेंगे नए एक्सपेरिमेंट के साथ।
Yeah, see the next one, screw gauge.
हेलो फ्रेंड्स, मेरा नाम वर्षा पारक है। आज हम पढ़ेंगे स्क्रू गॉज। स्क्रू गेज प्रैक्टिकल छोटे छोटे इंस्ट्रूमेंट्स को मेजर करने के लिए यूज किया जाता है।
Radius of thin wire.
ये स्क्रू गेज छोटे से
So normally we will be using it to measure radius of thin wire, thickness of the thin sheet. All such things can be measured. Means those thicknesses and radii are millimeter and less than that can be measured using this screw gauge.
25 मिलीमीटर, ये 15 मिलीमीटर, इससे और छोटे भी आते हैं, इससे और बड़े भी आते हैं, जिसका मेजरमेंट आप कर सकते हैं। स्क्रू गेज प्रैक्टिकल में हम छोटे से छोटे इंस्ट्रूमेंट का डायमीटर फाइंड करेंगे। फाइंड करने से पहले हम आपको बता दें कि इंस्ट्रूमेंट का स्ट्रक्चर कैसे होता है, कंस्ट्रक्शंस कैसे होता है। तो ये जो हम सर्कुलर स्केल को घुमा रहे हैं, आप यहाँ से देख सकते हैं, इस चीज को स्टड बोला जाता है। क्या बोला जाता है? स्टड। ये यू फ्रेम होता है, इसका स्ट्रक्चर इसलिए ऐसा बना जाता है, यू फ्रेम का बनाया जाता है। देन उसके बाद यहाँ आपको एक स्केल दिखाई दे रही हो जो खुलते जा रही हो, ये होती है मेन स्केल। ये 15 मिलीमीटर दिया हुआ है, तो ये मेन स्केल कहाँ तक होगी? 15 मिलीमीटर तक होगी। सर्कुलर स्केल हमारी 100 भागों में विभाजित है, या 100 डिविजन्स होती है। ये आपको दूसरी जगह ये दिख रहा है, इसको हम बोलते हैं रैटचेट। रैटचेट का मतलब होता है, अगर आपको कोई भी ऑब्जेक्ट कसने के बाद आवाज आती है, तो इसका मतलब आपका ऑब्जेक्ट पूरी तरह से कस चुका है और अब आपको वहां से रीडिंग लेना स्टार्ट करना है। ठीक है, अब आपको यहाँ पे मैं बता दूं पिच क्या होता है। बहुत सारे एक्सटर्नल वाइवास क्वेश्चंस में पूछते हैं कि पिच क्या होता है। तो पिच, आपको यहाँ थ्रेड्स दिखाई दे रहे हैं, बहुत सारे थ्रेड्स। इन थ्रेड्स में 1 थ्रेड से 2nd थ्रेड तक के बीच की डिस्टेंस को पिच बोला जाता है, पिच। अब हम प्रैक्टिकल स्टार्ट करते हैं। प्रैक्टिकल स्टार्ट करने के लिए हम किसी भी ऑब्जेक्ट को, छोटा से छोटा ऑब्जेक्ट लेते हैं। जैसे मैंने एक वायर लिया हुआ है, वायर का हम स्क्रू गेज से प्रिसिशन निकालेंगे, मेजरमेंट करेंगे। पर उसके पहले मैं आपको बता दूं रीडिंग लेना कैसी है। हमने एक चार्ट बनाया है, चार्ट में मैंने आपको दिखाया है कि मेन स्केल किस तरह से है। यहाँ पर ये मेन स्केल है। मेन स्केल के पास ये एक लाइन दिखाई दे रही है, कुछ इस तरह से लाइन दिखाई देगी आपको। यहाँ पर एक छोटी सी लाइन दिखाई देगी, वो छोटी लाइन इस सर्कुलर स्केल के जिस भी पॉइंट पर मैच कर जाए, किसी भी पॉइंट पर मैच कर जाए, तो वहां पर हमें रीडिंग लेना है, मेन स्केल की भी और सर्कुलर स्केल की भी। अब है पॉजिटिव एरर, जीरो एरर एंड नेगेटिव एरर। अगर जीरो, पूरा प्रैक्टिकल हमने बंद कर दिया और हमारे प्रैक्टिकल में जब लाइन बिल्कुल एक्यूरेट जीरो की लाइन है, मेन
So I
स्केल
am
की
closing
लाइन,
this. Let us go to our
सर्कुलर
page.
स्केल की लाइन जीरो एक दूसरे
ఏంటా సౌండ్లు? ఏంటయ్యా సౌండ్లు? చూసారా ఎక్స్పెరిమెంట్ ఎలా చేయాలో?
Yes, sir.
I think Meenakshi might have got that because she already did it, right?
Yes, sir.
So both fixed and movable jaws on both the sides of the vernier calipers are used, including that lever at the back side. So this is how they can calculate the internal diameter of the beaker, external diameter of the beaker, and even volume. Everything you can measure using the vernier calipers, and the radii of thin wires plus thickness of thin sheets can also be measured using the screw gauge. So here, just for idea sake, we got the diameter of the beaker. You can take it as a problem also. Diameter of the beaker. Their MSR, same values I am taking. A 6 centimeters, and vernier coincidence, that is represented by N. So we got 4. Least count is 0.01 centimeters. So diameter of the beaker is given by MSR plus VC into LC. That is, I gave the formula as A plus B. B is given by N into LC. So it is 0.04. Therefore, the diameter of the beaker is internal diameter of the beaker is given by, it is 6.04 centimeters. From this, radius is given by d by 2. So this is 3.02 centimeters. Then we got the depth of the beaker as 8.8 something. 8.83 centimeters is the depth we got. Here A is 8.8, N is 3. So height is equal to, or depth is equal to A plus N into LC. This is how we get 8.83. So if you want to find the internal volume of the beaker, then it is formula into
Pi r square h.
pi r square h. Okay, అర్థమైందా? ఏమయ్యా మాట్లాడలేదు?
Yes, sir.
Yes, sir, I got it.
Yes. Similarly, suppose you are given a rectangular sheet. You wanted to find the area of this sheet. Then what we do? We'll keep fasake antunnadu kada. So yes, you fix it between the two jaws of the vernier calipers like this. Then measure the MSR, that is A is equal to some 2.4 centimeters, just like that I am putting.
Sir, but if we put it between the two jaws, won't the sheet bend?
Without bending, you should not
Okay,
apply
sir.
your force. Understand? Yeah, if you apply your
Yes,
force
sir.
on the glass beaker, the beaker will break. You should do it gently. Okay, na? Yeah, among 10 divisions, check which first division of vernier scale coincides with the main scale, that is N. Let us say it is some 6. Then A becomes, A plus B will be 2.46 centimeters. That is the breadth or thickness or breadth you can put. Similarly, if you want to measure the length, hold the sheet between the two jaws like this. And again, take the main scale reading. A maybe 5.2 centimeters. Vernier coincidence, maybe it is some 4. So length is given by 5.24 centimeters. Therefore, area is equal to length into breadth. Therefore, it is 5.24 into 2.46. Calculate the area. Here, find the volume. Okay. Volume will be in centimeter cube.
Once can you scroll up?
Area will be in centimeter square. Understand?
Yes, sir, got it.
Yeah, this calculations you are supposed to do it. So here, first of all, we calculated the internal volume of the beaker. Next, here we are trying to find area of rectangular sheet. Okay, na? Yeah, please note down and do the calculations. వీడియోస్ ఒకసారి ఫ్రీ టైంలో చూస్తే మీకు ఇంకా క్లారిటీ బాగా వస్తుంది. కాపీ చేసారా?
So 1 minute.
Done, sir.
Next, this one. అయిపోయిందా?
1 minute. 1 minute.
Okay,
Done, sir.
good.
Sir, can you scroll?
Done, sir.
There once, sure, sir.
Sir, can you show the rectangular figure?
So breadth is equal to 2.46 centimeters. Length is equal
Done,
to
sir.
2.24 centimeters. Area you have to calculate. Okay, na?
Done, sir.
This. Yeah, this is what we did yesterday, right? I've shown you the least count formula and even the measurements were directly from the diagram what is given here. So everything we have seen. Now this is what you mean by screw gauge. So screw gauge works on the principle of screw. Okay, it has given all the parts. This is ratchet.
Sir, do we have to draw these?
No need. I'll share this. You can have it. Okay.
Okay, sir.
Yeah. So this is circular cylinder and with a scale on it that is called as the head scale or circular scale. And this is the cylinder to which a screw is attached. So when you are turning the cylinder in clockwise or anti-clockwise sense, if you rotate the cylinder in anti-clockwise sense, the screw will be coming up. And if you rotate the cylinder in clockwise sense, it will be going down. So thus, this is directly connected to the screw. And this is, yes, this is another scale called pitch scale. It's also called main scale. Pitch means the distance moved by the screw in one rotation. That is called pitch. So least count is least count for the screw gauge is given by least count of the screw gauge is given by pitch of the screw by number of main scale divisions. And pitch of the screw also has got a formula. Is PS. This is given by distance moved by the screw in one rotation. distance moved by the screw in one rotation, that is called pitch of the screw. Normally it will be 1 millimeter and number of head scale divisions will be 100. Therefore, the least count of screw gauge will be 1 by 100 millimeters. That is 0.01 millimeters is the least count of the screw gauge. So this is how it looks like. This is called index line or reference line. So as shown in the video, the wire whose diameter is to be measured will be kept here, and the screw is pushed down till both stud and screw are tightly holding the wire. Then we'll note down the main scale reading or pitch scale reading and circular scale reading, and the formula for diameter is given by PSR, pitch scale reading, plus N into LC. N is nothing but the circular scale reading, CSR. PSR ante pitch scale reading, formula raskondi. Diameter of thin wire, please write screw gauge, put the heading screw gauge. Put the heading screw gauge. And in that first you write the least count. In screw gauge, first least count. Pitch of the screw by number of main scale divisions or circular scale divisions. Number of main scale divisions or circular scale divisions. And pitch of the screw means distance moved by the screw in one rotation is equal to 1 millimeter. So normally pitch of the screw will be 1 millimeter. There are 100 main scale or circular scale divisions. So this will be 1 by 100 means 0.01 millimeters or 0.001 centimeters. So using screw gauge, you can measure even up to 1 by 1000th of a millimeter. Sorry, 1 by 1000th of a centimeter. Okay. This is first.
Sir, and what is the diameter?
I'm telling first least count and pitch of the screw you finished, na?
Yes, sir, done.
Yeah. Next, diameter of a wire. Diameter of a wire or thickness of a thin metallic sheet. Diameter of a wire or thickness of a thin metallic sheet is measured, is obtained using the formula.
So can you wait a minute?
Diameter of a wire or thickness of a thin metallic sheet. Thickness of a thin metallic sheet is given by D is equal to PSR plus N into LC. PSR plus N into LC. So ikkada readings ela untayante.
So can you show that one? Yes, sir, done.
Do you know how the readings will be? You are given a wire. So the PSR, here also you can call it as A, maybe 1 millimeter. And HSR, head scale reading or circular scale reading, N. This is given by some 63. Least count 0.01 millimeter. So diameter of the wire is given by the formula
PSR plus
HSR in
and
LC. అంటే D is equal to A plus B. B is equal to N into LC. So A is 1 plus B is 0.63. So diameter of the wire is 1.63 millimeters. So radius of the wire 1.63 by 2, 0.815 millimeters. This is how they measure the diameter of the wire or the thickness of a thin plate, etc., thin sheet, etc. Please note down. అందుకే స్క్రూ గేజ్ కూడా చూపించాం, మీకు ఐడియా ఉంటుందని. నిన్న వెంటనే షేర్ చేసింది ఎందుకంటే కాస్త చూస్తే క్లారిటీ వస్తుంది. I tried to give you clarity with the help of these diagrams, where even the zero error and all were very clearly shown. Positive error, negative error, అన్ని క్లియర్ గా ఉన్నాయి కాబట్టి I picked up these diagrams and explained you based on them. ఓకేనా? అయిపోయిందా?
Sir, in diameter of the wire.
Okay. So I can also add one more line. Screw gauge works on the principle of screw. Last లో note and bit రాసుకోండి.
Sir, screw gauge works on.
Wait, let them complete.
Okay.
Screw
Sir.
gauge works on the principle of screw.
Yes. Screw gauge works on the principle of screw. అయిపోయిందా?
Yes, sir.
No, sir. No, sir.
కాస్త ఫాస్ట్గా రాయాలి. మీకు మరి ఫ్యూచర్లో జేఈ అవి రాయాలంటే స్పీడ్ కావాలి. స్పీడ్ విత్ యాక్యురసీ. స్పీడ్ ఒక్కటి ఉంటే మళ్ళీ సరిపోదు. హైవేస్లో చూస్తున్నాం స్పీడ్ థ్రిల్స్ బట్ కిల్స్ అని. సో హియర్ ద మోటో ఈజ్ స్పీడ్ విత్ యాక్యురసీ. ఓకేనా?
Done, sir.
గుడ్. అందరూ అయిపోయిందా? హర్ష, హాసిని, హర్షిత?
Sir, all
Yes, sir, done.
Yes, sir.
Yes,
Done.
sir.
Okay.
Done with the note, sir.
Good. So this is about the positive error and negative error. If the zero of the head scale or circular scale coincides with the index line, then no zero error. Here, if the zero of the circular scale lies below the index line, positive error. If the zero of the circular scale lies above the index line, negative error. Here zero is lying below the index line, positive error. Whenever positive error is there, correction should be negative. Here zero of the circular scale lies above the index line, so negative error means correction is positive.
Positive.
Okay, this is about the vernier calipers and screw gauge. Then we have the measurement of mass. Yeah, next point. ఎంత సీరియల్ నెంబర్ ఎంతమంది ఎక్కడున్నాం? ఫస్ట్ మెజర్మెంట్ ఆఫ్ లెంత్ కదా అయింది.
Sir, 2, 1.
యా, రోమన్ నెంబర్ 2
2, 3, sir.
అయిపోయింది ఇంకా. దిస్ ఇస్ రోమన్ నెంబర్ 2. ఓకేనా? మెజర్మెంట్ ఆఫ్ మాస్. Put the heading measurement of mass. Measurement of mass. There you write mass of a body is measured. Mass of a body is measured using simple balance. Mass of a body is measured using simple balance or common balance or beam balance. Mass of a body is measured using simple balance or common balance or beam balance. Right in the next line, it works on the principle of movements. మనకి రాబోయే చాప్టర్స్ లో చెప్తాం. It works on the principle of movements. బంగారం షాపుల్లో ఎప్పుడైనా చూసారా? ఒక గ్లాస్ ఎంక్లోజర్ లో ఉంటుంది బ్యాలెన్స్.
Yes, sir, I saw.
So the gold ornament, either bangle or ring or anything whose mass is to be measured will be kept in the left pan, and the small weights will be placed in the right pan. So it will be swinging, the beam will be swinging for a particular weight in this pan. The beam perfectly remains horizontal. Then the mass of this gold ornament will be equal to the masses of these marbles placed in the stone. You call it as M1 is the unknown mass, M2 is the known mass. This is unknown mass.
So do we have to draw that also?
No need, no need. I'll share this class today. You can have it, okay?
Okay, sir.
This is known mass. So when the beam remains perfectly horizontal, then whatever mass you place, known mass you place in the right pan will be equal to the mass of the ring or any other gold ornament or any other object placed in the left pan. And in olden days, the Kirana merchants were having these beam balances. That is a simple beam balance. This is a highly sensitive beam balance. You can measure even up to 1 milligram. So you can measure from 20 grams to 1 milligram, and even half milligram also you can measure. So smaller masses can be measured so accurately using this beam balance or simple balance or common balance. Okay na? Asera point adi?
So can you repeat?
Have you written that?
So can you repeat?
Principle of movements avi rasaru kadamma?
Yeah, sir, we wrote it.
Yeah, below that you write the unknown mass of the body placed in the left pan of the balance. The unknown mass of the body placed in the left pan of the balance. Left pan of the balance will be equal to.
So can you repeat from left?
ఏమ్మా వినబట్టలేదా? ఏంటి ప్రాబ్లం ఏంటి? నాకు I don't understand.
No, sir, it's audible, sir.
Okay, right. The unknown mass of the body placed in the left pan. The unknown mass of the body placed in the left pan will be equal to the known mass of the body will be equal to the known mass of a body placed in the right pan. Placed in the right pan when the beam remains horizontal, when the beam of the balance remains horizontal. When the beam of the balance remains horizontal. Okay na?
Yes, sure. Done.
Next 2 lo second. spring balance. Two low second. This is called spring balance. Okay. So you will have a hook to hold it in your hands, and another S type hook will be there hanging freely. So the body whose mass is to be calculated will be hung from here. So whatever reading the pointer gives you on the scale will be the mass. In fact, it gives you weight. Please mention there. Second point in this.
Sir, they usually use this to measure weights for airports and things.
Yes, exactly. The mass of a body in kilogram weight. The mass of a body in kilogram weight can also be measured. Can also be measured. Can also be measured using spring balance. Using spring balance. The mass of a body, in fact, its weight. The mass of a body in kilogram weight will be measured using the spring balance. Okay. Third one, measurement of time. ఇవన్నీ మనకి ఆసిలేషన్స్ లెసన్ లో వస్తాయి, అందుకని ఎక్స్ప్లెయిన్ చేయట్లా ఇక్కడ. ఈ సింపుల్ పెండులం విల్ బి గెటింగ్ ఇట్ ఇన్ oscillations, hence I am just showing you the diagram. Yeah, measurement of time. First one, time is measured using a pendulum clock. Time is measured using a pendulum clock or a spring clock. కీ ఇచ్చేవాళ్ళం పూర్వం, గుర్తుందో అలారం టేబుల్ మీద ఉండేవి, మీ ఇంట్లో ఇప్పటికీ పాత ఉంటాయి. రోజు వాటి కీ ఇవ్వాలి, కీ ఇస్తే లోపల స్ప్రింగ్ వైండ్ అప్ అవుతుంది. సో ఇట్ వర్క్స్ ఫర్ 24 hours. Again, next day we used to wind up the spring. Even this wall clock pendulum, it used to work with oscillating pendulum. So pendulum will be like this. Yeah, please write measurement of time. First one, the pendulum clock.
So can you repeat? Time is measured using
Measurement of time heading low. First point, the pendulum clock is used. The pendulum clock is used to measure the times, to measure the time in hours, to measure the time in hours, minutes, seconds. Second one, some clocks were using working, you write, some clocks were working with wound up springs. Wound up springs. Now, third. Now all the clocks are working with. Now all the clocks are working with quartz or CCM. All the clocks are working with quartz or CCM oscillations. Now all the clocks are working with quartz or CCM oscillations, all digital clocks. Okay, na? Askunara? Harsha, Harshita.
Yes, sir. Rasas.
Yes, sir. Done.
Okay, good. Now this is measurement of volume, Amma. Fourth one, measurement of volume of fluids, volume of liquids. So there are different devices just for your
Measurement of volume.
of liquids. Measurement of volume of liquids. So write a sentence there. Volume of a liquid is measured in cubic centimeters or liters or ml. ml అంటే ఏంటి? milliliters కదా?
Milliliter.
Milliliter. Next line, the devices used are please copy them. Measuring jar, ఇంకొకటి measuring flask, third one pipette, fourth one burette. Measuring jar, measuring flask, కెమిస్ట్రీలో బాగా ఎక్కువ వాడతారు ఇవన్నీ. మెజరింగ్ జార్. ఏమో మీనాక్షి ప్రాక్టికల్స్ ఏం చేసావా కెమిస్ట్రీలో?
Yes, sir.
ఏమైనా చూసావా ఇవన్నీ?
Yes, sir. 6th లో చెప్పారు, sir.
ఓకే ఓకే. సో మెజరింగ్ జార్, మెజరింగ్ ఫ్లాస్క్, పిపెట్, బ్యూరెట్. So if you pour the liquid in a vessel, water and other liquids will have a surface bent downwards, kada? Whereas alcohol, mercury will have a surface bent upwards. Then meniscus antaru anamata dinni. It's called meniscus. So this is about the measurement of volume. Okay, and there are some diagrams, standard diagrams. Yes, ఇది ఒక్కసారి చూడండి సరదా బాగుంటుంది. Very interesting. See, this is the smallest radius of atomic nucleus will be in the order of Fermi. 1 Fermi, in fact, it will be 10 to the power of minus 15 meters. So nucleus dimensions will be in the order of Fermi, whereas this is the radius of atomic nucleus. So nucleus is radius is atom contains nucleus in it. So nuclear dimensions will be in the order of Fermi, and this is radius of an atom, angstrom units, 10 to the power of minus 10 is 1 angstrom unit. You may get questions based on these conversions of units of length. So 1 angstrom unit is 10 to the power of minus 10 meters. 1 nanometer, 10 to the power of minus 9 meters. And then the normal blood cells in our body, they will be in the order of microns. Micron is represented by mu m. So its value is 10 to the power of minus 6 meters. This is human dimensions will be in the order of 1 meter and odd. This is diameter of the earth will be in the order of 10 to the power of 7 meters. And the distance of earth from the sun, astronomical unit. Astronomical unit. Many people will confuse between angstrom unit and astronomical unit. Angstrom unit ante 10 to the power of minus 10 meters. And one astronomical unit is 1.53 into 10 to the power of plus 11 meters. Kada? Mean distance of earth from the sun. So this is 10 to the power of 26 meters is the limit of observable universe. Recently, we got pictures in which the newly sent Webb telescope moving around the earth has sent beautiful pictures of the neighboring galaxies and all. So these are the various dimensions of length we have. Some typical lengths in universe. This is of course from micro. This is to macro. I'll share this video. Of course, anyhow, all the classes I'll be sharing you today. Better you save this video because it contains some diagrams and all. So these are the different ranges of lengths from micro to macro. Okay, na? Vinnara class, vinnara?
Yes, sir.
Yeah. This is how they defined meter in terms of distance covered by the light in vacuum in 1 second. So this is approximated to 3 into 10 to the power of 8 meters in 1 second. So light is estimated to travel a distance of even a little higher standard, but just I'm giving you information. Don't worry that the understandable kadipudu. Just you learn it. Even we skip them even in 11th class also. So just for information I'm giving you, speed of light in vacuum is given by 3 into 10 to the power of 8 meters second inverse. So in 1 second, light travels a distance of 3 into 10 to the power of 8 meters. So light travels, exact value is this, I approximated. So 1 meter is defined as 1 by 3 into 10 to the power of 8th part of the distance traveled by light in 1 second. That is how we define 1 meter. Tarvata chundidi Severus near Paris in Japan, the International Bureau of Weights and Measures and undakada.
Yes, sir.
International standard for kilogram is kept in safe custody like this in that museum. There's International Bureau of Bureau of Weights and Measures. In that, the platinum iridium cylinder is kept in this evacuated jar so that its value will not get affected by the fluctuating physical conditions. Then same diagram in another reference book, Resnick and Holiday. This is Jimansky diagram. Okay, this is what I say cesium clock. The cesium atom will be making these many oscillations. So we say time taken by cesium-133 atom to make 9 point something, 9.192 etc. into 10 to the power of 9 oscillations is called 1 second. I repeat, time taken by the cesium-133 atom to make 9.192 into 10 to the power of 9 oscillations is called as 1 second. So in 1 second time, cesium makes these many oscillations. So this is how oscillations or revolutions, whatever it is, that is shown here in the diagrams. Okay. These are some additional supports I just wanted to give you. And this is the Leaning Tower of Pisa, from where the Galileo investigated the falling objects and measured time intervals. And here is the smaller and bigger units of length. I just mentioned them. Mass also 1 nanometer, 10 to the power of -9 meters. 1 micron, 10 to the power of -6 meters. 1 millimeter, 10 to the power of -3 meters. 1 centimeter, 10 to the power of -2. 1 kilometer, 10 to the power of 3. 1 microgram, 10 to the power of -6 grams, or 10 to the power of -9 kilograms. 1 milligram, gram. Similarly, times. These are the some units of length, mass, and time from bigger to smaller. Okay. మన పిచ్చి వెధవలో దీని inclination, this is vertical. This is Leaning Tower of Pisa. దీని inclination maximum ఎంత ఉంటుందంటే ఒక 12 degrees దాకా ఉండొచ్చు. Whereas in Varanasi, we have a temple. ఈశ్వరుడే టెంపుల్ అది గంగాలో మునిగిపోయి ఉంటుంది. ఎప్పుడు అబ్జర్వ్ చేశారో లేదో మీరు. ఐ విల్ ట్రై టు షో యూ దట్ డయాగ్రామ్. మరి ఇంకా ఇంక్లినేషన్ ఎక్కువ ఉంటుంది ఆ టెంపుల్ కి. ఇలా గంగ నీళ్ళలో మునిగిపోయి ఉంటుంది ఆ టెంపుల్. అబ్జర్వ్ చేశారో లేదో ఎప్పుడైనా. పీపుల్ విల్ బి గోయింగ్ ఇన్ టు ద టెంపుల్ అండ్ దే విల్ బి హ్యావింగ్ దర్శన్. గంగా నీళ్ళలో ఎప్పుడు అలా మునిగిపోయి ఉంటుంది. ఈ పీసా టవర్ కంటే కొన్ని వేల సంవత్సరాల ముందు కట్టిన టెంపుల్ ఇది, ఈశ్వరుడి గుడి. అది రిఫర్ చేయరు వీళ్ళు. దే రిఫర్ ద లీనింగ్ టవర్ ఆఫ్ పీసా. ఎందుకంటే అంతా దే వాంటెడ్ టు హ్యావ్ ద బాసిజం ఆన్ ఎవ్రీథింగ్ on the whole world. That's why they refer all these things. Even though many more complex structures are there in India, they are not referred. So this is all we have in units and measurements. Yeah, this is what I've shown you yesterday. Advantages and all we discussed. So today's class I'll be sharing you. Sir, chudandi vernier calipers, screw gauge also you can have them. And with this, I am concluding the second chapter, measurement. Okay, na?
Okay, sir.
Okay.
Next one is describing motion. Very important. We'll get good number of problems and all. So coming Saturday, there will be assignment. And after immediately receiving the key, I want your scores.
Okay, sir.
Not like last time. Okay, na?
Okay, sir.
Yeah, assignment, you will be telling you your scores. Test, we will be giving you the scores. Is it okay?
Okay, sir.
Yeah, assignment should be self-assessment. Test will be taken by us. Is it okay?